6.1. In this sessions, we're going to review the greatest common factor and factor by grouping. So first, the greatest common factor is basically we are trying to factor out the common factor from each term, and it must be the greatest from those terms. So let's take a look at on example 1a. There are a total of 3 terms in here. So from the first term, second term, and the third term, start with the numerical factor. So I have 5, 15, 20. All of them has a common factor of 5. And that will be the greatest common factor. So therefore, 5 out. And then the variable, m to the 4th power, m to the 5th power, m to the 4th power. So on every term, m to the 4th power is the common and then the greatest. So factor out m to the 4th. And lastly, x to the 3rd power, x to the 6th power, x to the 5th power. The common factor from every single term is x to the 3rd power. So I factor out x to the 3rd power. And that will give us our greatest common factor. Now we need to write it down what is left over from each term. From the first term, I factor out 5m to the 4th, x to the 3rd, so therefore it left with 1. Because you need to multiply by 1 to get the same again. And then plus, from the second term, when I factored out the GCF, it will left with 3 x to the 3rd power. So also m, right? So let's write it down in order. M x to the 3rd power. And the last term will be negative 4 x to the 2nd power, because m squared is factored. M to the 4th power is factored out. So this will be my final answer for A. B. In this example, we want to factor out negative as a GCF as well. So you can factor out negative 1 as the greatest common factor for any factoring problem. But however, we will only do that as we need it in the future. Let's take a look at on this example B, and then let's factor out a negative number as the greatest common factor. So first, you notice that there's 3 terms, and from each term, let's look at the numerical factor first. Negative 35, negative 21, positive 21, and negative 63. So negative 7 is the greatest common factor. Now you can always check that's true or not by writing it down. Negative 7 times 5, and then negative 7 times 3, and negative 3, negative 7 times 9. And you will notice that 5, 3, and then 9, all of these are not common factor. So therefore, finally, I can conclude that negative 7 is the greatest common factor for the numerical part. Continuing this, this will become m to the 2nd power, because I have the first term m to the 3rd, second term m to the 3rd, the third term m to the 2nd, so the GCF will be m to the 2nd. And lastly will be n, because I have n to the 3rd power, n to the 2nd power, n on the last term, so the greatest common factor is only n. And with this, it will help us to get our final answer by writing down what's left over in each term. That will become 5 m n to the 2nd for the first term. And because of you factor out the negative So the second term will become negative 3n and then n. And the last term will be plus, because you factor out negative, so it will be plus 9. And since m squared and n is factored out also, there's no more variable for this term. And this will be our final answer. Continuing, next example. Part C. Your greatest common factor is not necessarily only a monomial. It could be a binomial or it could be a trinomial also. Well, this is the example of it. So as you can see, my first term has two binomial multiplying together, which is the first binomial factor is a plus 2, and the second binomial factor is a minus 3. And the second term also has two binomial factor, a plus 2 and a plus 6. So from here, I can see that a plus 2 is a common factor. So factor out the greatest common factor, a plus 2, out. And the leftover from the first term is a minus 3, plus the leftover from the second term is a plus 6. Now simplifying a little bit, that will give me a plus 2. Take it out the parentheses, it will be a minus 3 plus a plus 6. And combining like term, which give us my final answer, 2a plus 3. D. Similar situation, but this time we will have to be more careful because it's mixed in with monomial and a binomial factors in each term. So the first term, my monomial factor is 12k squared. Binomial factor is a plus 5b to the third power. So let's take a look at, as usual, factor by factor. So the first one, we're going to look at the numerical part, 12 and 18 from those two terms. So 12 and 18, the greatest common factor is 6. And the next factor will be k squared and k. So the greatest common factor will be k from those two. And the last common factor will be the binomial a plus 5b. The first term has a plus 5b to the third power. The second term has a plus 5b to the second. So therefore, the greatest common factor will be a plus 5b to the second. So finally, we will write it down what is left over. So from the first term, this will become 2k and a plus 5b. Plus, from the second term, this will left with 3. That will be it because we factor out k and as well as a plus 5b to the second power. And this will be my final answer. You don't really need to simplify further because even though you distribute it, there's nothing you can combine like terms. So you may leave your answer as it is. And of course, on the quizzes or tests, if the final answer is simplified, then you can basically simplify and choose the right answer. Next up, we will take a look at on the greatest common factor. The greatest common factor is basically factor by grouping is basically you group two terms by two terms, or two terms with three terms, or one term with three terms, and etc. But in these sections, we will only review grouping two terms and two terms only. And then we will extend it out in a future section. So first step is you will group two terms by two terms, and then each group you will factor out the greatest common factor. If you group it correctly and factor out the greatest common factor correctly from each group, then we will be able to get something common factor that can be continued factoring. If it doesn't work, then you're going to have to regroup it in some problem and then try to factor it out if it is factorable. Okay, so let's take a look at on factor by grouping. So the very first problem, so A 6p minus 6q plus rp minus rq. So without thinking anything, this is what you can do. Group the first two terms together and group the last two terms together. And notice that the way that I group is underlining, so that way you can see on the third term I included the sign as well. Okay. So from the first group I factor out the greatest common factor, which is 6, and what left over is p minus q. On the second group I will factor out a positive r, so that would be when you factor out positive r, that will left over with p minus q also. See, notice that if you group it correctly and factor out the greatest common factor correctly, then we will have this situation, which is a binomial common factor that we will be able to factor out. So now the next step, to get our final answer, we factor out the binomial common factor p minus q, and then the leftover will be 6 plus r. And this will be my complete factorization. Example 2. Example B. xy minus 2y minus 4x plus 8. Once again, without thinking anything, we will group the first two terms and the last two terms. The first two terms, the GCF, the greatest common factor, is y. So this would left with x minus 2. From the second two terms, I will factor out the greatest common factor, negative 4. Because only if you factor out the negative 4, this term will become positive and this term will become negative, and that's what we want right here. So, speaking with that, factor out negative 4, and this will give us a positive x and negative 2 from that. So that's what I mentioned earlier. We will factor out the negative as we need it. So finally, I can see that there is a common binomial factor, which is x minus 2. And I factor out x minus 2, and this will left with y minus 4 as a second factor. And this will be my final answer. Next, C. Kn plus mn minus k minus m. Again, without thinking anything, group the first two and group the last two terms, which give us the greatest common factor from the first group will be n, and the leftover is k plus m. And from the second term, I can factor out negative 1 as the greatest common factor. So when I factor negative 1 out, this will become k plus m. Now we can see that k plus m is a common binomial factor, So I can factor out k plus m, and which left over with n minus 1 from both of the terms. And let's continue on example D. Example D. That is 10x squared y squared minus 18 plus 15 y squared minus 12x squared. So as usual, without considering anything, group the first two and group the last two. See we can factor it out or not. So from here, if I factor out the GCF from the first group, this will be just 2. So which will left with 9x squared, 5x squared, and y squared minus 9. And from the second group, at the GCF, when I factor it out, it will be just positive 3. So this will become 5y squared minus 4x to the second power. So notice that there is no, I don't have the common binomial factor at all. That basically means our grouping is not correct. We have to regroup it so that way it will help us to get the right answer. So there may be a several way to regroup in it. So it's depending on how you see on this regrouping part. Okay. So there's more than one way to regroup it. That's what my point is. So if I regroup in this, let's say I'm going to regroup 10x squared y squared plus 15y squared minus 12x to the second minus 18. And the reason why I do that, I rearrange it this way is because I already think about which two I'm going to put it together and then what is the second pair that I'm going to put it together. So look at it, the first two term, I have the greatest common factor y squared, and I have the greatest common factor 2. So if you factor a y squared out, I don't have any more y. And that's the same case that I'm going to get in the second two term. There's no more y. So let's check it out. So from the first two term, I factor out the greatest common factor. The number will be 2. Oh, no, the number will be 5, my bad. Okay. The number will be 5, and the greatest common factor for variable will be y squared. So what's left over is 2x squared plus 3. On the second two terms, right, the second group, I can factor out the greatest common factor negative 6, which will left with positive 2x squared and then plus 3. Now we have the common binomial factors, which I can continue factoring. This will become 2x to the second plus 3. That's the common binomial factor. If I factor it out, from this first term, it will left over 5y squared. From the second term, it will left over with negative 6, and this will be my final answer. So this is a way to regroup and then continue factoring. So example E. Example E, 2kp squared plus 6 minus 3p squared minus 4k. Notice that if I group the first two and the last two, in the first group, on the second term, I don't have any variable. On the second group, I have p squared and then k in each, p squared in the first term and then k on the second term. So it will not work out. So right away I can see that lazy way of grouping doesn't work. So we're gonna rearrange it. And when you rearrange it, it could be like in earlier, I will rearrange it 2kp squared minus 3p squared, so that way p squared will be the greatest common factor. And since the first term is 2k, so I want the first term on the second group also have k, so I put 4 minus 4k first, and then plus 6. Now, we group the first two term and the last two term. From the first two term, the greatest common factor is p squared, so which will become 2k minus 3. From the second group, it will be negative 2, the greatest common factor, right? So that will left with 2k minus 3 because you factor a negative out, so the sign changes also. So from here, I can see that the binomial common factor, which is 2k minus 3, we factor it out, and then the leftover from the first term will be p squared, and the second term was 2, and that will be my final answer. And then last example F. P squared q squared minus 10 minus 2q squared plus 5p squared. So similarly, you can see that this term has no variable. So if I group the first two term and the last two term, it will not work because the last two term, the first one has q squared and then the second term has p squared. So rearranging it. So as usual, I'm gonna try to put something that's together first. So it'll be p squared q squared and a minus 2q squared, right? Minus 2q squared. So that way, if I factor out q squared, I will left with p and 2. So since on the first group p first, so I will rearrange it this way: plus 5p to the second minus what? 10. So now I can basically group the first two term and the last two term. And always notice that when I underline the last two term, I include the sign of the third term also, right? So that way you can consider clearly what sign we need to factor as well. So this will become, from the first group, the greatest common factor is q squared. So this will left with p squared minus 2. And from the second group, the greatest common factor is positive 5. So that will left with p squared minus 2 as well. So finally, I can see that the GCF binomial, it will be p squared minus 2. So we factored that out and left with the first term, q squared, the second term, plus 5. And this will be my final answer. And that concludes the section 6.1.